Okay, so in this problem, we are going to find the local extrema or relative extrema of the function f of x equals x cubed minus 3x squared over 2 plus 7 using the first derivative test. So the first thing that we have to do when doing the first derivative test is to find our partition numbers. And the partition numbers are everywhere that the first derivative is equal to 0 or does not exist. We know that as when you have a function, a derivative function, as some fraction. So we'll say g of x over h of x. Then to find where it equals 0 or where it does not exist, you want to take the g of x or the numerator and you want to set that equal to 0. And then you also want to take h of x, your denominator, and set it equal to 0. And that's going to tell you where your derivative equals 0 and where it does not exist. Okay, so let's start this off. First, we're going to find our derivative, f prime of x. The derivative of x cubed is 3x squared. Remember, you multiply the exponent out front. That's where the 3 comes from. And then you subtract 1 from your exponent, which gives you 2. If we do the same thing with this 2, multiplying it out front, we're going to end up with 6 divided by 2, or negative 3, times x to the 2 minus 1 is just first power. And finally, the derivative of 7 is just 0. So we end up with 3x squared minus 3x. And we want to set that equal to 0. Since it's just a polynomial, there is no fraction here, like in the case above it, then we can just set this equal to 0 to find all of our partition numbers, which gives us 0 is equal to 3x squared minus 3x. And from here, all we have to do is factor and set each factor equal to 0. So we get 0 equals 3x times, notice we can factor out a 3x from each of these. So we get 3x times x minus 1. And now we can set our 3x equal to 0, as well as our x minus 1 equal to 0. And if we divide each side by 3 on the first case, we'll get x equals 0. And in the second case, if we add 1 to each side, we'll get x equals positive 1. So these are our two partition numbers, but in order for us to use them in the first derivative test, they have to be critical numbers. And the only way for them to be critical numbers is if we can plug them into the original function f of x and get a real answer. Meaning we now need to find f of 0 and f of 1. So starting with f of 0, we get 0 cubed minus 3 times 0 squared over 2 plus 7. And our first two terms are just going to end up being 0, which will just leave us with 7. Remember, in our class, you can just immediately plug that into your calculator and just get your 7. Then we're going to plug in our 1 to get 1 cubed minus 3 times 1 squared over 2 plus 7, which ends up giving us 6.5. So at this point, both of these are real numbers, which means both of these partition numbers are critical numbers. So we can use both in the first derivative test. So remember, with the first derivative test, the first thing that you want to do once you've found your critical numbers is to make a table. We're going to list our x value and our derivative function, f prime of x. And we're testing the values around 0 and 1. So to test a number to the left of 0, we're going to test -1. We need to test a number between 0 and 1, which will be 0.5. Then a number greater than 1, we'll try 2. So if we plug -1 into our derivative, we'll end up getting 3 plus 3, which would be +6. All we care about is that this number is positive when we're doing the first derivative test. From there, we plug in our 0.5. When we plug in 0.5, I'm just going to quickly do this on a calculator, just for the sake of time. We end up getting -0.75. Which ends up being less than 0. So again, all we care about is that this number is negative. And finally, when we plug 2 into our first derivative, we get 3 times 2 squared is 12, minus 3 times 2 is 6. So 12 minus 6 is +6, which again, all we care about is that it is positive. And remember, the first derivative test says all you need to do is, when you make this table, you go to your critical numbers and you check what is the change in sign of our first derivative around this critical number. Meaning, we went from a positive to a negative for our first derivative. So if you were to draw that, you'd go from a positive slope to a negative slope, which means you have a local maximum. You have a hill, so you have a maximum value. And then from there, at our value of 1, we went from a negative to a positive. So if you drew a negative slope and then changed to a positive, you have a valley, which means you have a local minimum. So now we just want to list each of these. We have the point 0, comma, and now we'll go back to our function value we did over here. We have a 7. So 0, comma, 7 is a local maximum. And now we go to our other critical number, 1. So we have 1, comma, and over here we got 6.5 is a local minimum. And these are the local extrema or relative extrema given the function x cubed minus 3x squared over 2 plus 7.